Managing secrets across multiple third-party services requires you to build and maintain custom rotation logic for each platform, leading to hard-coded credentials and operational overhead. AWS Secrets Manager now supports managed external secrets for MongoDB Atlas and Confluent Cloud. You can rotate MongoDB Atlas and Confluent Cloud secrets automatically using partner-provided rotation logic without deploying Lambda functions in your account. You can manage database user and service account credentials centrally for both platforms, including SCRAM authentication and OAuth secrets for MongoDB Atlas and API keys for Confluent Cloud service accounts. You can eliminate custom Lambda functions for secret rotation since AWS Secrets Manager handles the entire rotation process. The integration supports cluster scope and cloud resource management keys for Confluent Cloud, with automatic rotation enabled by default. This allows you to centralize secret management for data pipelines using MongoDB Atlas and Confluent Kafka without modifying application code or managing separate rotation logic for each service. When you register EC2 SQL Server HA clusters to reduce license costs, an invalid HA configuration can lead to unexpected billing charges if the system cannot verify your high availability status. You can now receive notifications when Amazon EC2 cannot detect a valid SQL Server HA status. You receive alerts when HA status cannot be detected, ensuring you maintain awareness of your cluster configuration. You access notifications via Health Dashboard and Event Bridge, providing multiple channels including email for visibility. You respond quickly to avoid unexpected billing costs by addressing configuration issues before they impact charges. This capability is available in all EC2 SQL HA supported regions, including AWS GovCloud US regions, giving you consistent monitoring across your deployments. Organizations need to adapt foundation models to their specific domains without managing infrastructure or building models from scratch. You can now fine-tune Qwen 3.54b, 9b, and 27b models on SageMaker AI to incorporate your proprietary data and domain knowledge. The service supports both supervised fine-tuning and reinforcement fine-tuning methods to specialize models for your use cases. SageMaker AI provisions and manages all infrastructure automatically, allowing you to focus on your data and evaluation while paying only for actual usage. This enables you to tailor model outputs to match your terminology, quality standards, and organizational requirements without cluster management overhead. The feature is available in US East, US West, Asia Pacific Tokyo, and EU Ireland regions through SageMaker Studio or the Python SDK. Building agent prototypes requires writing orchestration code, managing agent loops, and handling deployment workflows, slowing time from concept to production. AgentCore now provides a managed harness that lets you define agents by specifying a model, system prompt, and tools, then run them immediately without orchestration code. The harness manages reasoning, tool selection, and execution while providing microVMs with file system and shell access. You can persist file system state externally, allowing agents to suspend mid-task and resume exactly where they left off, maintaining context across sessions. When ready for production, you can deploy agents using the AgentCore CLI with infrastructure as code governance through AWS CDK, with Terraform support coming soon. The CLI includes pre-built skills optimized for coding assistants like Kiro Power, Claude Code, Codex, and Cursor, providing accurate AgentCore guidance directly in your development environment. These features work together to accelerate the full agent lifecycle from prototype to production deployment. When you use services like Amazon EKS, ECS, Lambda, or Workspaces, they provision EC2 instances and associated resources that AWS manages on your behalf. Previously, these managed resources appeared alongside your self-managed resources in EC2 console views and API responses, creating confusion about which resources you are responsible for managing. With Managed Resource Visibility settings, you can now control whether these AWS managed resources appear in your console and API operations. New managed resources are hidden by default from Describe API responses and console views, helping you focus on the resources you actually manage. You can separate AWS managed resources from self-managed resources to better understand your infrastructure. You configure visibility through the EC2 console or AWS CLI based on your operational needs. This alignment with the shared responsibility model clarifies which resources AWS manages and which you manage, reducing clutter in your resource views and API responses. Software updates to your OpenSearch Service domains previously offered no self-service option to revert to a previous version if you encountered issues after applying an update. This left you without recourse when updates caused problems in production environments. You can now roll back service software updates within 15 days of application, giving you control to recover from problematic updates. You initiate rollback through the new Rollback Service Software Update API, AWS CLI, or the OpenSearch Service console. The rollback process uses a blue/green deployment to safely revert your domain to the previous software version. This capability is available across all AWS regions where OpenSearch Service operates. Monetizing live streams has been challenging due to AD blockers and complex client-side integrations that disrupt viewer experience. Amazon IVS low-latency streaming now supports server-side ad insertion to address these issues. You can stitch ads into live streams via Media Tailor integration, which handles ad decisioning, audience targeting, and personalization on the server. You can insert ad breaks using an API operation during streaming, giving you control over when ads run. You can reduce ad blocker impact with server-side stitching since ads become part of the stream itself. When you record streams to S3, IVS includes ad markers in the recording, allowing you to monetize recorded content with on-demand ads as well. Previously, SageMaker Unified Studio projects were limited to one Jupyter Lab space and one code editor space, restricting your ability to work on parallel work streams with different resource requirements. You can now create and manage multiple code spaces within a single project for IM domains, enabling parallel work on different experiments or tasks. Each code space maintains its own persistent EBS volume, preserving files, data, and session state independently. You can scale compute and storage up or down per space, pause and resume them at any time, and customize the runtime environment for each task. Spaces can be opened in dedicated browser tabs or connected to your local IDE with full functionality including Amazon Q paid tier support. This enables you to run parallel data transformation and model training workloads within the same project while maintaining isolated environments for different work streams. GPU-accelerated workloads like Gen AI inference require specialized hardware management to mitigate failures and minimize disruption. Amazon ECS now addresses this by continuously monitoring NVIDIA GPU health and automatically replacing impaired capacity. You can detect GPU failures through integrated NVIDIA DCGM monitoring that identifies critical hardware issues. When failures occur, the system automatically replaces impaired instances to maintain workload availability. You can monitor GPU health status through the Describe Container Instances API and receive event bridge notifications when instances become impaired. For scenarios where you need manual control, you can opt out of auto repair at the capacity provider level and implement your own remediation logic. This capability is enabled by default on all supported NVIDIA GPU instance types at no additional cost across all AWS commercial regions.